Hello everyone, welcome back to my videos. So in the last lecture, we talked about how to prevent the overfitting. I mainly covered there are two solutions to prevent overfitting. The first one is that we can have more data, but sometimes it's very hard to get more data. So in this scenario, we can use other linear regression algorithm, such as regularized linear regression. And to introduce this concept, I have used two examples to help you understand this, what is regularization linear regression problem. And after these two problems, I formally introduced the mathematical equations. Actually, what the regularized linear regression is doing for us is that we will not only minimize our residual sum of squares, we will also minimize the weights in our model. So by doing this, we can prevent our model from becoming too complicated. And this is the intuition behind the regularization. And we have covered that there are three kinds of regularization. The first one is the ridge regression, also is called the L2 regularization. And the second is the Lasso regression, also is called L1 regularization. And the third one is a combination of ridge regression and lasso regression. And we give it a name as elastic net regression. And we have also talked about the difference between the ridge and the lasso regression. The difference is that in lasso regression, the weights can be minimized to zero. So some features can be dropped. And in ridge regression, all the weights cannot be minimized to zero. It will only be minimized to very close to the value of zero, but it will never reach to the value of zero in ridge regression. And we introduced that in the objective function of regularization term, there is a coefficient that is called eta. We call it eta as the regularization coefficient. Sometimes you may say eta as lambda. That's all the same. These are all regularization coefficient. And we said that this is a hyperparameter. And this is a new term. And in this video, I'm going to talk more about this hyperparameter. And we have also introduced when eta increases, how our training error and our testing error will change. Okay, these are some main concepts we have talked about in the last lecture. So in this lecture, I'm just I will talk more about the hyperparameter and we'll wrap it up and on the hyperparameter, and I will also talk something on how to tune our hyperparameter. Okay. So here, let's talk something about hyperparameter. Hyperparameter. And before you heard about the hyperparameter, you heard about this terminology, you must have heard about what is parameter. So in linear regression, our parameter is nothing but the weights omega. So the weights vector omega. And now this terminology is changed to hyperparameter. And sometimes it's very easy to confuse between these two, to get confused between these two terminologies. And one first thing you should keep in mind that hyperparameter and the parameter are totally different. They are totally different terminologies. So hyperparameter and parameter are totally different. They are totally different. And how they are indifferent is that, firstly, the hyperparameter, such as the eta, such as our regularization term in our regularization linear regression problem, hyperparameter is this eta is manually chosen. So it is not learned from the data. We give this hyperparameter, and they are usually manually defined. For example, in our previous example, in our ridge regression, we can give eta as we can set eta as 0. When we set it as 0, it's just normal linear regression. We can also set it as 0.1, and we can also further increase the eta we have talked about. Maybe you can set the eta as 2, as 3. As you increase the eta, the model will become much simpler because you are putting more emphasis on minimizing the weights instead of the minimizing the training error here. Thus, this coefficient is set by you, by the machine learning designer. So this is why we call it hyperparameter. And on the other hand, parameter. Therefore, parameter is not manually defined. So parameter are usually parameters are learned from data. For example, in linear regression problem, what is parameters? We say that the weight vector omega is a kind of parameter. So we usually learn this omega from our model. For example, omega in linear regression is parameter, not hyperparameter. In linear regression, if you remember in the normal linear regression problem, how we can learn this omega from the data is that we will minimize the residual sum of squares of our models to all the training points. This is how our omega is learned from data. So this is the first very important difference between hyperparameter and parameter here. And the second point you should keep in mind about hyperparameter is that each machine learning algorithm will have unique hyperparameters. For example, in our regularization linear regression problem, our hyperparameter is this eta. We have only talked about this algorithm, so in the future we will talk about more models such as KNN or random forest. So in those models, the hyperparameter will be different. They will not be this eta, they will be something else. Therefore, you should keep in mind that in each machine learning model, they will have a unique hyperparameter. Just like everyone has our own name. So each machine learning model has their own hyperparameter. And another point is that hyperparameter needs to be tuned in validation set, or sometimes this set is called development set. Okay, here you may ask if this hyperparameter is manually defined, so which one we should use eventually? We should use this one or we should use this one? So this process is called hyperparameter tuning. And this process, this tuning is usually done in a data set that is called validation set or development set. So these two names are the same. They both refer to the same data set. Okay, and let's maybe do a review, because here actually I have talked about what is validation set in the first video, and here let's do a review on this. Let's suppose I will draw a circle to represent the data we have, and suppose we have all the data, and the data percentage here in this circle is 100%. So we have all the data here, and we usually will split the data first, and we usually split most of the data, most percentage of the data to the training data set. And let's draw something like this. Okay, let's suppose we split 80% of the data as the training data set, as the training data, and we have 20% left. And let's suppose we give 10% as our testing data. And we have 10% left. So we give this 10% data as the validation data. Okay. And you may be very familiar what we will be doing in the training data set. We will train our model here, right? But you may get confused what's the difference between the testing data and validation data. What will we do exactly in these two data sets? Okay, and how we fulfill this hyperparameter tuning in validation set and training data set. I may give you a workflow like this, and this is also concluded by myself and some materials from the internet. And let me write it here, and I call it hyperparameter tuning workflow. Okay, so in real practice, how we will tune our hyperparameter and find the optimal hyperparameter and to use the final optimal model. Okay, so below is what we will be doing. Firstly, we will, let me change the color here. We will train different models with different hyperparameters. So you should keep in mind that we only train our model in the training data set. Train different models with different hyperparameters in training data set. Okay, I should emphasize on this. you should remember that all of our model is all trained from training data. It cannot be trained on testing data nor validation data. So we will choose different hyperparameters and we train different models in a training data set. And then what we will be doing is that when we were training these models, we will verify these models. We will evaluate these models in the validation dataset instead of testing dataset. We will evaluate these models with different hyperparameters in the validation dataset. So this is the purpose and usage of the validation dataset. Let me write it here. These models are evaluated in validation or development dataset. Okay, so here you should not use testing dataset. You should use validation dataset to evaluate the performance of these models. So the performance would be, for example, the arrow, the residual sum of squares, or the mean squared arrows. You will use some arrow functions to measure this performance of our models here. Okay, so you can see we have different models and we have evaluated their performance in the validation dataset. So then we can choose the optimal model with the smallest arrow, right? Okay, so next step is easy to understand. We just select the optimal model that has the best performance. Okay, this step is just we select the best model based on training dataset and validation dataset. So this step is very easy, and we just select the best model we want. And after we have selected the optimal model, and we can observe from this that we have used this dataset and we have used this dataset, but at this moment we didn't use the testing dataset, right? So in the last step, we will be using the testing dataset. So here is how we can use the testing dataset. And the last step would be we will decide the final performance of the optimal model on testing dataset. Okay, so the last step will involve the testing dataset here. Okay, you may see that in step 2, we have evaluated the performance of our model, but here we evaluated the performance again. And here you should clear that this evaluation is the evaluation between the different hyperparameters, between the models with different hyperparameters. And then we choose the best performance in order to determine the hyperparameter. After we have chosen the hyperparameter, we also need to evaluate the performance of this model on some other dataset to decide the final performance of our model. So here, so that is what we are doing here in the last step. We chose the best model and we evaluate its performance again, but this time is on a totally different dataset It's on the testing dataset. So the testing dataset is used to evaluate the final performance of our model, to see how our model chosen here will behave. Okay, and here, so these are all I want to cover in this video, and here I just wrapped it up on what is hyperparameter and how we can tune hyperparameter in practice, because these steps may sometimes get confused on how we can tune the hyperparameter. Okay, I will stop here. Thank you.